fairly confident this is recording now, but we'll see. It's no disaster if it's not. Okay, so this week we're going to be talking about scope. But as I said, I have to correct the record from something I said last week. And I am truly embarrassed by this because I used to be the logic teacher at the last school that I worked at, and I taught you something totally wrong about logic. So I said something along the lines of or and are associative operations, which is true, but I may not have made this clear. And only is an associative operation, and or only is an associative operation. As soon as you mix them together, it's not associative anymore, right? So this slide is a lie. Don't believe this slide, right? So the only reason this worked out with the bracketing is because I happened to pick something that worked by accident, right? So I'm going to replace the first thing in there, the 3 greater than or equal than 3, by 3 greater than 3, and we'll see that it won't work. Okay, so this is a slight modification to the last slide. So how does this resolve? Okay, let's not answer that question yet. I'm going to type this into Python and see what it says. It says true, right? So according to Python, if you type that into the console, it's going to give you true. Yes? Oh, that was, okay. You rose your hand. That's sort of the universal symbol for I have a question, but okay. So let me bracket around the second, like, Boolean. Let's bracket around the or. So 3 greater than 3, false. False and, huh? What's the only case where and can be true? Both are true. So if the first one's false, then the whole thing is false. Well, that's a problem, right? I told you that's not to be the case, right? So what happens if I bracket around the first thing? Then I get false or true, which is true. Okay, so clearly this is not associative. So I apologize for teaching you something wrong. I don't know where my head was at, but at least I'm correcting the record at the moment. And I corrected last week's slides, and I re-uploaded them. So you may want to delete whatever's on your computer and download the new versions of the slides. But we've learned an important lesson, right? These things aren't associative. So I did it deliberately for the purposes of demonstrating something. But let's continue down this line of reasoning. Oh, so here's just a statement that I'll throw in there, right? So consider that true or false and false gives true when you give it to the Python interpreter. And that statement is ambiguous because depending how you bracket it, it's going to give you a different result in either case. So this means that it's going to be necessary for us to just define an arbitrary order of operations on and or, right? So you look very, what's with the confusion? So is this correct? True or false should give you true. Oh, I've swapped these. It's great that I make mistakes when trying to fix mistakes from the last week. Okay, these are swapped, right? This true or false is true and false is false. I'll fix that. True or anything is true, right? So this is swapped. This is harder than it looks, guys. Okay, so we're going to, so what can we deduce from this, right? Yeah. Yeah, and specifically, what is the order? Yeah. So if we look up here, Python will evaluate ands first, and then ors second, okay? So to be very clear about this, if there is ambiguity in a logical statement, bracket the ands first, and then the ors second. The not is a unary operation, and unary operations always occur first. Right, so I'm not even going to bother putting not in there, but if you wanted to, the order of operations are first, not, then and, then or. And there's really no other reason than besides because we said so. Right? We have to agree on an order of operations just to get rid of ambiguity. So it could have easily been the other way around, but it isn't. So there you have it. Back to regular scheduled programming. I wrote that last night, and I'm like, oh yeah, we are literally going back to regular scheduled programming. And then I laughed to myself. I live a very sad life. A little bit of warm-up before we begin function scope. And I'm going to yell at you a little bit in the second slide. So if I define a function which takes no input and returns 9, and I call it, what should happen? And I want to be very specific about things today, right? About it will, like, if it prints nothing, I want you to say nothing will print. And if it prints something, I want you to say something will print. And these three greater than symbols indicates that we're in the Python interpreter and not making some external call. So assuming we're in the Python interpreter and this has been typed, I type foo, what prints, right? Nine. It's 9. 9 prints. Okay, that was supposed to be the easy one. Okay, so that's what I want to yell at you guys about this print statement, but we'll get to it, right? What about this one? So I define a function called bar, which takes a value x. It sets x to 8 and then returns x. So if I call bar of 1, what will happen? If I call bar of 2, what will happen? All right. Okay, here's a function which is going to square a value, and I've defined it like this. Okay, what happens when I do this? No. What prints or doesn't print? Okay, 4 will print, right? Because you told it to. Is this true? What is true? Okay, you all went silent, so I can sense that there is some confusion here, right? But like, let's look at this, because this is very important, right? Printing something to the screen just prints something to the screen. It doesn't store the value, it doesn't put it anywhere, it simply prints it to the screen. If you don't put a return statement in your procedure or function, it's going to put one there anyways. It's just going to assume the last line of your function is a return, and if you return nothing, it will return none, right? So if you're printing instead of returning, you're going to print something to the console, but it is 100% wrong. Why? Because if I assign the square of 2 to a, I expect a to have the value of 4, right? Anything else is wrong, right? So I don't know if this is some misconception that you guys sort of developed in high school, but functions are just mappings. When we tell you to design a function that does something, follow the design specifications, right? Any ambiguity regarding what you should do is on us, right? If we told you to do something and didn't tell you to write test cases, don't write test cases, right? Because if we come back and said, you didn't write test cases, you can say, you didn't ask us to, right? So any ambiguity in the instructions is on us, the instructors, right? So if you guys want to do the minimum amount of work, just follow the instructions precisely. Okay, so do we understand this? Right? You must return. And furthermore, don't print. There are very rarely circumstances where you're going to actually need to print anything. It's mostly debugging, right? Which means that your function is broken somehow and you're trying to see what values are set where, which can also be accomplished via the debugger, right? So really, you never need to use a print statement, right? You're not writing user interfaces. You're not interacting with the user. You're writing single functions that are going to be used by other functions. So furthermore, suppose I really did ask you to write the square function, and then I'm going to develop a library of mathematics, and I'm going to square stuff like 1,000,000 times. Do you think I'm going to be happy that 1,000,000 things have been printed to my screen? No, right? Because print is the most expensive operation in that routine. Print is very slow, right? Because you have to wait for access to the output device and then write. So not only are you irritating me by printing a bunch of stuff to the screen that I never expected to be printed, you're also slowing down the computation by showing me what you've been outputted. So, return. Do not print. Right? Well, there was about 100 questions on Piazza regarding this, right? So yeah, so again, return, don't print, and when we give you an instruction, follow the instructions, right? This is something that I cannot repeat enough. Follow instructions, and don't invent new ones, right? A lot of people asking, oh, how should I write my test cases? We never asked you to write test cases. Or how should I throw an error? We never asked you to throw an error, right? Just follow instructions. Because when you go to a company and they say, design me a function which does this, you better design a function which does that and only that, right? Because side effects that aren't in the design description, that will get you in trouble, right? So let's break that habit now, right? Prints, we don't really need them. Okay, so some more warm-up. So I define this function foo, which returns x plus 2 and returns x plus 3. What's f of 10? Why? Everything after the first return is ignored, right? Even other returns, right? If I set the answer, if I assign the result of f of 10 to answer, what gets printed? The answer's nothing. Nothing gets printed, right? Because you're doing an assignment. How do I print the value of answer? So print answer is one option. If you're in the interpreter, if you're like in Python itself, I can just type in answer and hit enter, and it will print 12. Right? So everything after the first return statement is ignored, because at that point you've already exited the routine itself. Here's a new one, right? I've swapped out the returns for prints. Oh, and somehow they're missing the brackets. I'll fix that. What's f of 10? What prints to the screen? 12 and, right? Because there is, so where's the return here? What are we returning in this function? Nothing. No, right? I'll repeat it again. If you don't put a return statement in your function, Python is going to assume you are returning nothing, right? That you are in fact defining a procedure, right? So if I do this, what gets printed? Well, nothing. Oh, I tricked myself. Let's try that again, right? If I assign the, yes? Oh, yes, that should be a foo, not an F. Lots of mistakes yesterday, right? This is the first, okay, so not only is this the first time that I'm teaching this course here, you are the first lecture, right, in that sequence, right? So I get to correct all this stuff for tomorrow's class, right? So they think I'm a lot smarter than you guys know. You guys know the truth. Anyways, okay, so I'm going to call foo of 10, right? So I'm going to assign the result of foo to answer, right? And since you're printing, it's going to print, right? The print will always print. But what is the value of answer? None. I heard none somewhere, right? So answer is none. Yes?
The first, where you said f is 10, it shouldn't be 12, 13, because you're not resetting the value.
12, 13. I don't know what I was doing last night. Right. I'm going to show you something, right? Shh. This is how the slides look like to me, right? So, like that's like this is what I see basically, right? So, although it looks like the mistakes look huge and obvious, where did it go? They look huge and obvious in the slides, but they look tiny. Like they're tiny when I see them, right? So, feel a little bit sorry for me, but it's good. It's good that you're catching these things. It means that we're learning, right? It makes it a lot more interesting. Okay, so yes, this should be 12. This should be 13. I couldn't even copy properly. I don't know how that 14 got there, right? Anyways, the point of this is that, right, printing and returning are totally different, right? And so don't print, right? Printing is just going to mess things up, right? Okay, so now the true meat of today's lecture, right, we want to talk about the scope of a variable, right? So suppose a computer program creates a variable. There are going to be places that the program can access that variable and other places where it cannot access that variable. When I say places, I mean functions, control structures like loops and if statements. So here's a few more examples. Okay, so x is 2, y is 3. I'm going to define this function foo, which returns x. I'm going to define a function bar, which returns foo times y. And it's foo with these brackets, right? It's a function call to foo. Without the brackets, it becomes a name, a variable, right? So I probably should have made a slide like that for the next class. What gets returned? Okay, what about this? Okay, so you see that this x and y was defined outside of a function. So these functions get access to those variables. So these variables, x and y, are what we call global, right? Because their scope is the entire program. So globally is as big as you can be in a Python shell. A global variable, or sometimes we simply say global, is ones that can be accessed by all functions. Anything declared outside of a function will be globally accessible, except there's a little bit of nuance to that. A function declared globally is said to have the global scope. By convention, so you generally should not use global variables, right? Because that could have a lot of weird side effects. But there are instances where you should use globals. For instance, constants, right? If you want to use pi, yeah, okay, pi is going to be the same everywhere. So you can go ahead and define a global variable called pi. The PEP standard regarding this is to use caps, right? So anything in caps is a variable that shouldn't be changed. So like in programming languages like C, you can actually declare a constant and it will prevent you from modifying it. In Python, nothing would actually stop you from changing pi to 7. It's just that you know, so using this convention, if you see something that's like all caps, you should know, oh, I shouldn't change the value of that. That's meant to be left alone. So a lot of the things we do in Python are styles that help you realize what things are. And it will help keep things in your mind organized. Okay, so let's practice a bit. Or I'm going to try to trick you in a bunch of ways. So I'm going to set x equals 2. I'm going to create a function called foo. And I'm going to call foo. And then I'm going to ask what the value of x is. So what are your guesses? Who says 2? Who says 7? It's 2. Why is it 2? Okay, so this gets confusing, right? Because these x's have the same name. But, so it would be irritating if every function had to use different names, right? So I like using x. So it would be a disaster if the x of foo is the same x of every single other function, right? So instead, foo has what is called its own namespace. So everything defined in foo is accessible locally to foo. Although this is confusing because there are the same names. Okay, so in order to make this less confusing, I can tell foo that the x that it's using should be in fact the global x. You have to tell it, right? So don't make a local variable, use the one that already exists. So when I do this, and now I call foo, what should the value of x be? Okay, good, we're going well. So it is a good idea, right, whenever you're using a global variable, to specify it. Right? The Python interpreter will let you not specify it, but I recommend that you do. Right? That way you know clearly what variable has what scope. Like you'll introduce a lot of weird bugs into your program with global. So just be careful with them. I'm going to define a function called foo. I'm going to set x equal to 2, and then I'm going to return x. What does foo print? 2. What's x?
None.
Error. So we have two scopes here. We have the scope of Python itself, and we have the scope of foo. Right? The x is declared locally to foo. Right? So that means the only thing that can access x is the function foo. So thereby, if I ask for the value of x outside of foo, Python doesn't know what x is. It's saying, well, we're in the global namespace now. There's no x. Right? So you may have to go home and play with this a bit. Yeah?
Is there a way to call the x library inside of foo.x?
You're getting way ahead of ourselves. And so if there's a, we'd have to define an object first. Right? And that's, I don't even think we're going to touch objects this semester. But like, then those cease to be functions. Right? That's something. That's a structure. That's something else entirely. But yeah, that's exactly why objects exist, right? So we can have this type of interaction. Okay. I'm going to define x equals 2 in the interpreter. I'm going to define foo. I'm going to say x is equal to x plus 2, and I'm going to return nothing. So I'm going to call foo. What happens? Who says error? Why?
Because x is not defined function, so you're trying to add 2 because you don't define 2.
Sure. So this one's a tad confusing, right? So there is a global variable that's set to 2. So this technically should be 4. But when Python reads this line, it's reading it left to right. And it's saying, oh, okay, x. Okay, so I should declare a local variable named x in foo. And I'm going to assign to my local variable x, which is now has been already loaded as a local variable. And it's like, well, x doesn't have a value yet, right? So it says, look, you can't do that. You can't assign x to be a value that's unknown, right? So the point is, by the time the compiler gets to here, x has already been casted as local. Yeah.
In the first line, let's say we change x to g, for example, and then so the line that you're at right now, let's made it x is equal to g plus 2. Would that result in error?
No, because we'll have a different, I think maybe I have that slide comes next. Okay, so as I said, it's better to specify when something is global. So if I call foo now, and which returns nothing, what should the value of x be? Right? So I call foo, it walks into here, it says, oh, there's a global variable that I should be using here called x. Here it looks at this and it says, okay, so I have the global x is equal to the global x, which is 2. So this gets evaluated to 4, and then it puts 4 into x, right? So x gets a new value, 4. If I call foo again, what is the value of x? 6, right? I'm just updating this global variable x, right? It's not like the function keeps returning to the first line, right? Every line runs exactly once, right? We're returning to this line through this invocation, but it's not like this x equals 2 gets run like every time, right? So that it's set once, and then its value is incremented as we run this procedure. Yeah.
In a function, once you write global x, it assumes global x from then onwards.
Oh yeah, because like every time you invoke that function, the first line is going to be a global x. Yeah. Okay, x equals 5. I'm going to define foo that takes x and returns x. Right? What is foo of 7? 7. Let's walk through this. So this will pass the function foo a value 7, which gets set to that x, and then it returns 7. Okay? As soon as you do this, as soon as you make a function argument, it becomes local, right? So already here, x has been made local, right, to the function foo. Right? So if I do this, what's the value of x? 5. So despite having the same name, right, the two x's live in different name spaces. One is global, and the other one is local. Right? So when you're messing around with the local one, it has no effect on the global one. And when you're messing around with the global one, it has no effect on the local one. Right? This is basically the entire point of scope. Right? So, and you're gonna have to play around with this a little bit in the lab and like at home in order to really get a full appreciation of this. X equals 5, and I'm going to define foo, which takes y and returns x times y. Right? What is foo of 7? Okay, let's walk through this. Right? So I call foo with 7. It goes up to here. It replaces this y with this 7, and then it returns what? X times 7. And in this case, x is a global variable assigned to 5, so this should return 35. What about this one? Let's walk through it. So foo is a function which is going to be passed x. What is the value of x? 5. So it sets y to 5 and returns x, which is 5, times 5. 25. Yeah. Pardon me? Because if you don't define it, it's going to assume it is global. Right? If there's a global variable available, it will take it. Which is precisely why I'm saying make it explicit. Even though you don't have to, make it explicit. So it would have been better for me to put a global x in here. I'm just trying to show you some of the nuances, right? Here's an instance where I'm trying to declare. I just feel some of you may try this, so I don't want you to be off-put when you see this error. Why am I getting this error like this? Right, so as I said, making a variable a function argument will cast it as local. So by this point already, Python says x is a local. And now you're saying x is a global. And now Python's going to say, well, you can't have it both ways, mate. Right? It has to be a local or a global. Pick one. Right? So don't do that. Right? You can't mix global and local variables. And at least in this case, it's going to throw you an error. So is there any questions regarding that before we move on to something else about scope? Because I'm happy to sit here in compiler and play around. Anything at all? Okay, so what I recommend is you definitely need to do the lab on this, and you should definitely go home in your Python shell and play around a bit, right, to see how these variables interact, because it's definitely confusing for new programmers, right? Because especially when these names are the same name. Yes. Well, every function will return at least none, right? If you don't write a return, Python's going to assume there's a return nothing there, right? So the question, if I understand, is if I call foo of 6, what will be returned? Okay, so for this function, okay, actually let me just type it. So I have def foo. So what did I do here exactly? Oh, okay. What? X equals 5. Def foo of x, global x, and what did I say? Return nothing. Oh, I can't do that. So let's just redefine this. Well, I'll say 2x, right? Return. Okay. So the question was, what should return if I do this? Does anyone know the answer? Oops. So this really seems to be a point of confusion. And I don't really understand why. All functions, a function is a mapping, right? So you're going to have to map to something, right? Including nothing, right? So every time you define a function, something will be returned. And if you don't include a return statement, Python is just going to return none for you, right? So how can I help unpack this for you guys, right? So like what happened in that function, right? Foo took the value 7 for x. It evaluated 2 times x, 14. It didn't do anything with it. It didn't print it. It didn't store it anywhere. But nonetheless, it still calculated 2 times 7. It's going to do exactly what we asked. And then it's going to return nothing. Okay, so let's try another one. Bar of x. 2 times x. No prints. 2 to the power of 2 and 2 plus 3. And return. Or I won't even return. I'll do that. Okay? What will be printed if I do this? Nothing. What if I assign a to bar 3? What is a? Nothing. Right? So again, this is the main problem, and I'll go over it again because it does seem to be confusing. Right? If I do something like create a function called add, and I just do this, right? It's going to look like it's working, right? And I think that's basically the problem, right? But again, if I want to set answer, right, like this, right, that's a problem that answer hasn't been assigned the thing that I expected it to. Why? Well, because answer has been assigned none, right? Because despite the fact there wasn't a return statement included here, there is one implicitly there that's returning nothing. So how can I fix this? Right, return x plus y, right? So we can add 2 and 3, we can add 7 and 10, and here's the problem, right? It looks basically virtually the same with this important distinction. And I wouldn't even call it an important distinction, I'd call it an absolutely critical distinction, yeah. Pardon me? Oh, sorry about that, guys. How about that? What? What? What's the problem? I should go back to how I went? Oh. You guys should have said something earlier. I'm just assuming what I can see here, you can see up there, but... All right, well... Okay, just remind me next time about this. Sorry about that. You can see the slides, though, fine, yeah? Okay. Sorry about that. Is this more clear now? Okay. So I don't know how many times I can repeat this, but one more time. Print, bad. Return, good. Right? So, and it's basically because of this, right? I'm expecting your function to actually return the computed value, right? And although it looks identical in terms of doing this, right? It's not the same thing. Okay, so please remember that for the next assignment, which is a serious one. Okay, so in this week's lab, there's reference made to something called the design recipe. And I'm going to post the design recipe to my sort of section of the course website. So one of the other professors for this course wrote basically like a recipe for how to write a function. And I'm going to walk through that recipe with you, even though I'm not a big fan of recipes, but this one isn't a bad recipe. Okay, so suppose you want to write a function, right? And it's not a function that we have assigned to you. You, honest to God, are writing some project and you need to define a function. Step 1, name your function. What's a good name? Well, a good name is something that very quickly tells you what the function does. Okay, but you have to balance telling me what the function does with having an enormously long function name. Right? So try to find some type of balance. Right? So a function name that is like, this function returns the sum of two numbers. That's a bad function name. A better function name would be add. Right? So if you can understand, just try to come up with a good descriptive function name that's not too long. Right? That's step one. Step two, assume your function works perfectly. How is it that you want to call it, and what should it return? Right? So just assuming that your function works. So I'm going to write a function called isPrime, right? Which should, what do you think my function isPrime does? Determines if a number is prime or not, right? So that's why it's a good name. Assuming that my isPrime function works, I want to be able to call it like this. So it's my desire to call my function isPrime at 7 and for it to return true, and for me to call my isPrime function at 8 and for it to return false. That's my desire, right? So right? It's good to imagine how you would want your function operating in the wild, right, before you start designing it. Step 3, write a short and concise description of your function, which certainly shouldn't be longer than the function itself, unless your function is doing something so complicated that it's like based on a scientific paper. But none of us are at that level. So here's a short description of what this does. This function returns true only when x is a prime, right? So this is a very good, concise description, right? So basically, steps 1, 2, 3, I can summarize as write your function header with a docstring, right? That should be step 1. Step 4, write your function. And I won't, because in this instance, writing the isPrime function is super difficult. But return your answer. Should we print the answer? No. Should we return the answer? Yes. Okay, so that's step 4. Step 5, test your function. Right, so you should at least ensure that your function works on the test examples that you wrote. And you also want to test your function on like really weird cases. Right, so does anyone know what ever heard the term corner case?
Are they like example cases?
Every corner case is an example case, but not all example cases are corner cases. A corner case is like some weird, like technically allowed input that is like really weird. So it's hard to come up with an example here, but suppose my function was instead called isEvenPrime, right? So can anyone give me the single okay. 2 is a kind of a weird prime number because it is the only prime number which is even, right? So a prime number is only divisible by itself in 1, right? So thereby no other prime except for 2 can be even, right? So if I wrote a function isEvenPrime and I just returned isPrime, a corner case in that function would be 2. It's just like a weird special thing that doesn't necessarily conform to the overall pattern, right? So basically this means try and break your function, right? See if you can break your function. Next time we're going to start writing more functions. As soon as I get loops and if statements, I swear to you, we can do stuff that's more interesting. Yeah, so I'll see you next week.